So 2022 paper 2, and we're working on question 8, and this is the deferred paper. So a farmer employs 14 workers to sort, pack and load egg boxes for delivery. They work in groups of 5 at any one time. Find how many different groups of 5 workers it is possible to form. Okay, so this, out of the 14 that he has on his books, he chooses any group of 5. So 14 choose 5. So we can do that direct and 2 ways in which he can actually form a group of 5. Part B, a farmer has a coded lock on his office. He has forgotten the code. The code consists of one letter, so one letter, followed by, so for example, A6465. So we can also see there that repetition seems vowel. Okay, so it's not the entire alphabet, but he knows it's a vowel. So there are 1, 2, 3, 5 vowels. So he has 5 choices for the first letter. He also remembers that the 4-digit number begins with a 6. So we've only one choice there. It has to be 6. And is an odd number. So if we think of all the digits that are available to us, we know 5, 7, and a 9. So we have 1, 2, 3, 4, 5 choices there. Now, given the fact that we seem to be allowed repetition, then we have 10 choices for the remaining spaces. So we multiply each one. So 5 by 1 is 5, by 10 is 50, by 10 is 500, by 5 is 2,500. So there are 2,500 possibilities for this code, for this farmer's code. The farm shop sells boxes of eggs. The table below shows the price of each box, as well as the probability that a box of eggs that is sold is of a particular size. Find the expected value of the shop's income from the sale of one box of eggs. Give your answer in euro, correct to the nearest cent. Now, expected value, that's usually to do with, is it a good bet? Is it a bad bet? Like they were the examples that we mainly did, but it's the same idea. So if we're doing the expected value, we need to multiply the price. So usually that would be the amount you could win. In this case, it's the amount, I suppose, you get when you sell, and you multiply it by the probability. So the probability is 0.1. Again, what you see, 2.35 multiplied by 0.19. Okay, so let's figure that out. So from here, I'm just typing into the calculator. So each one, just putting it in as I see it there on my screen. Okay, so the answer I'm getting is 1.7975. Now, because we're dealing with money, it'd be €1.80. So the question was, give your answer in euro, correct to the nearest cent. It says it there actually. So that's our expected value. The farmer's eggs are classified for sale in different sizes according to their weight. Each egg is either small, medium, large, or extra large. The weights of the eggs are normally distributed. So straight away, we're talking about a bell-shaped curve. The mean weight is 60. The standard deviation is 15. So if you're one step above, that's going to be 25 grams. And you can continue, doing each of the standard deviations, but that's just a sketch to get us started. An egg is small if it weighs less than 53. So 53 is somewhere in there then. So it's considered small if the weight is less than that. So we're talking 53 grams. Work out the percentage of the farmer's eggs that are small. Give your answer correct to the nearest percentage. Okay, so what we really want to do is find the probability that the eggs will be less than 53 grams. That's what we're actually trying to do. But I suppose we're reliant on our log tables. So remember, from page 36 on, we have these Z scores, okay, which is our standardized scores. So, and if you remember, standardizing was where the mean is considered 0, and we have 1, 2, 3, and so on. So each of our standardized and -1 the other way, and so on. So the problem here is that when we use our formula, so x minus the mean all over the standard deviation, we're going to do phi all over the standard deviation, which is 15. Now, the problem is when we do that, I already can tell this is going to be negative. So that's negative 0.46 recurring. Now, does that make sense? Well, it does make sense because that orange line there is in between a standardized score of 0 and -1. So it does explain why it's negative 0.46. So what we're going to do, I suppose, to get around that is we're going to have to find out what it is. So our log tables give us the positive version. So if we find out what it is going this way, we'll be able to do it on our log tables. And then all we have to do is take it from 1 when we're done. And that will actually give us the section we're looking for, which is the left-hand side of the orange line. So that's what I'm going to do. So on page 36 of my log tables, I find now it's 0.46 recurring, so 0.4666. So really it's on our log tables, it's 2 decimal places. So it's really 0.47 for the sake of our log tables. So when I look that up on page 36, 0.47, I'm reading here is 0.6808. Now, again, that makes sense because we're talking about the pink section. So it's, you see the way it's more than halfway? So that explains why it's 0.68. So all we do now is we do 1 minus that number, and that will tell us what is in the section we're actually looking for. So 0.8. Okay, so we're getting 0.3192. And it says, give your answer to the nearest percentage. So it's going to be 32%. So we expect 32% to weigh less than 53 grams.